Carbohydrate Catabolism Procedure by Navni Plaha and Darlene Wolosky. Hypothesis. We believe that the germinated peas will have a higher rate of cellular respiration than the ungerminated peas. This is because germinated peas need energy to divide, which they get from cellular respiration, unlike ungerminated peas, which don't need a high amount of energy because they don't divide. Therefore, they don't have a high rate of cellular respiration. That is our reasoning for our hypothesis. Procedure. On our bench, there were 2 bottles labeled germinated and ungerminated, and we fit the rubber stopper with the attached glass tube into the respiration bottles. We submerged the rubber tubing into the water-filled test tubes at our bench. We inserted the rubber stoppers and took note of the time and incubated for 60 minutes. After the 60 minutes, we replaced the water in each test tube with phenol red, and we resubmerged the rubber tubing below the surface of the liquid. We then removed the rubber stopper from the top of the jar and slowly poured water into the jar. The carbonic acid displaced and moved into the rubber tubing into the tube filled with phenol red. The yellow color is the indication of acidic conditions. These are our results. The first video will show when we poured water into the ungerminated peas respiration bottle. We inserted the water into the large beaker, and if the carbonic acid is produced, an indication of cellular respiration, then it bubbled into the test tube of phenol red. In the presence of carbonic acid, phenol red turns yellow. And you can see that Darlene in this video is pouring water into the ungerminated peas. I'm going to fast forward to the end of this, and then you can see our results. And it still stays red. That means that there was no there was no significant cellular respiration that occurred in the ungerminated peas. Now I'm going to start the germinated peas video. This is our germinated peas, this is our beaker of phenol red, our small test tube of phenol red. And you can see that Darlene is once again slowly pouring water into the germinated pea respiration bottle. I'm going to fast forward towards the end again, so you could just see our results. And you can see that the phenol red turns orange. Actually, I'm just going to show you a little bit of it turning orange. And you can see that it's starting to turn orange because of the yellow and the red mixing together. And that indicates that in the germinated pea, cellular respiration did occur. Our conclusions. Our hypothesis was correct. Cellular respiration was much more evident in the sample of germinated peas rather than the sample of ungerminated peas. This makes sense because germinated peas need more energy because they need to divide, and the energy that they get is made from cellular respiration. This is for our second experiment, and we believe, and our hypothesis was, that the boiled germinated peas will not undergo cellular respiration, and our reasoning for this was that cellular respiration requires enzymes to function, and in high temperatures enzymes denature. Therefore, cellular respiration does not occur. Procedure. We place the peas into the respiration bottle. We then fill the respiration bottle with boiling water. Then we submerge the rubber tubing into the water-filled tubes at the bench. After 60 minutes, we replace the water in the test tube with phenol red. We resubmerge the tube once again, and then we remove the rubber stopper and replace the water. Then we measure the displacement of carbonic acid. These are our results for the boiling peas. We inserted the water into the large beaker, and if CO2 is produced, an indicator of cellular respiration, then it bubbles into the test tube phenol red. In the presence of carbonic acid, phenol red turns yellow. And you can see in our video that Darlene is pouring water into the germinated boiling respiration bottle. Right next to the phenol red is phenol red attached to the respiration bottle is a standard bottle of phenol red to compare it to. And I'm going to skip forward so you can just see our results. As you can see, the phenol red did not turn yellow, so there was no cellular respiration. And as we predicted, the boiled peas did not undergo cellular respiration. This proves that enzymes control chemical reactions in cellular respiration, and this is why cellular respiration did not occur in the boiled peas, because boiling water denatured the enzymes. The temperature was just too high. Thank you for watching.